So I'm doing this question. A balanced die is tossed 720 times. So this is just a dice, like six-sided dice. So n equals to 720 times. And then they say find the probability that six will all come as follows. 110 times. So the probability of success will be given by success is 1/6. And then this is how many times you have to just get it. So it's P of X is let's say at least 110, so it will be 110. So now from here you have to approximate it. So to approximate it, let me just indicate it as nearer, which is P of X, which this one falls into 110 minus 1/2. So now what you need to do is you need to just get the answer for that. So that's P of X greater and equal to this will be 109.5. So that's your final answer there. So now let's come back here. So to standardize something, you need the mean and you need the standard deviation. And these are given by n times p. That's the mean of success. And then this will be n or square root of n times q times p. So it doesn't matter what order you give them there because you just times them. So what is q? Q will be given by the complement of the probability of success, which is 5/6. So okay, now let's work them out. So this one will give you n times q 720 times 1/6. So it's basically just divide by 6. That gives you 120. And then this one will give you, so you can just times it by q, and it's times 5/6. That's 100. Square root of that, that's 10. So standard deviation is given as 10. So now you have your answers there. Now let's transform it, which is basically standardizing it. So you transform it. Note that this is like a big binomial distribution. This is part of like binomial. It's actually called approximation to the binomial distribution. So they give you similar things to binomial distribution, but now you're working with like big number. Remember, binomial distribution, you can work up, I mean, let's say from 1 to like 15. We can calculate that. But then once it gets over that, then you have a big problem because now you have to just basically approximate. So they say the remark says the larger the number of n is better approximation becomes the normal approximation is used only when n times p is greater than 5. So where n times p, this number, is greater than 5, then you can approximate it. You can apply this part. And then when the probability of success, the mean of success is greater than 5 and the mean of failure are also greater than 5, then you can use approximation. So this is approximation that we use it. You'll find it in your book on page 53. And then if they're less than 5, then you don't use this part. So okay, you don't need to do this part. So okay, now what was I doing here? Oh, this is just part of the explanation that I was doing. Let me just erase that. So now, okay, now what we need to do next is basically find the answer for that. So let's transform this guy. So it's P of Z is basically, now we can just say greater than without the equal sign. And now we can work with what we usually work with, our normal numbers. So this will be 109.5 minus 120 divided by 10. So now 1.05, which is a good enough number. So this will be a complement of 1 P of Z less than equal to 1.05. So that's your answer there. Now, let's just quickly look at this table. So we're looking at 1.05, 1.05. It's this number. Where is it? 5. Yeah, there. 5 is 0.8531. So 0.8531. This is minus that one. So you will get just quickly 1 minus 0.8531. That gives you 14. So this will be 0.14. I don't know why this thing is cracking like crazy. 0.14 69. So that's your final answer. So that's all for this video. Thank you.